Hello everyone. In the today's session we will discuss about the Kubernetes administrations. So let me start first about the introduction. Kubernetes are ancient Greek words for the helmsman or the pilot of the ship, initially developed by the Google, has its origin in Borg Cluster Manager. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. Place containers on nodes. Recover from failure. Basic monitoring, logging, health checking enables the containers to find each other. So basically, Kubernetes is automating deployment and management of containers which hold the applications. Now proceed to the next thing. See, it's a open source container orchestrating tool. It manage Docker or its container, those are containing the different types of applications, and helps to manage the containerized application in different deployment environment like desktop or on any cloud. In anywhere we have to deploy the applications. Now let's see about the basic concepts related to the Kubernetes, like Kubernetes Master. It's a main node or the computer maintain the desired state for the cluster, and the Kubernetes node, it's basically like client run the applications, and the Kubernetes objects abstractions that represent the state of the cluster, right? A record of intent, a desired state of the cluster. Objects have a spec describe its desired states. States describe the actual state updated by the Kubernetes name. The client provided unique for a kind in a namespace can be reused. Namespace, the virtual cluster provide a scope for names, label, key value pairs attached to the object. Label selector is the core grouping primitive annotations. Attach the arbitrary non-identifying metadata to object. Now proceed to the next thing. See, this is the main master node. Through virtual network, it's connect to the different clients like node, different node, that is known as the worker node, and all these we can manage and control through the master node, that is main system. Now let's see the Kubernetes objects categories, like workflow used to manage and run the containers like pod, replication controller, deployment, discovery, and the like aspects workload together into an extremely accessible load balance services like service and ingress, config and the storage. Objects we can use to inject initialization, data into an applications and to persist data that is external to the containers. Volume secrets. Metadata, like objects used to configure the behavior of other resources within the cluster, that is limit range. Cluster, the objects responsible for defining the configuration of the cluster itself, namespace or binding. So a Kubernetes cluster consists of the component that represent the control panel and a set of machine called nodes. When you deploy Kubernetes, you get a cluster. A Kubernetes cluster consists of a set of worker machine, that is worker node, called node, that run containerized applications. Every cluster has at least one worker node. Now proceed to the next thing. See the Kubernetes architecture, Kubernetes Master and the Kubernetes nodes. See this? The Kubernetes Master consists API server, etcd, scheduler, controller manager, and the Kubernetes nodes, kubelet, kube proxy, container engine, and the pods. So the number of users connected to the Kubernetes Master. This is the architecture of Kubernetes. Now let me discuss one by one. Kubernetes Master, then Kubernetes Node component. Now the Kubernetes Master provide the cluster's control panel. Kube API server exposes the Kubernetes API, that is the front end for the Kubernetes control panel through which you can connect, and the desire to scale horizontally. etcd is the backing store of Kubernetes that store all the things related to the Kubernetes, the data and the node backup, all these things. Distributed key value store. Kube control manager, background threads that handle the routine tasks like node controller, replication controller, endpoint controller, and the service account and the token controller. Kube scheduler assign the nodes to the newly created pod. Now proceed to the next thing. See, master node architecture. It contains like API server, controller manager, scheduler, and etcd. API server, through we can connect through the user interface or through API or through command line. And what is the role of API server? Entry point to the Kubernetes cluster, through which we can manage all the things. The second thing is control manager. It keeps the track of what's happening in the cluster. Next is scheduler. Ensure the pods placement. And the next is etcd, that is Kubernetes backing store. It can store all the things related to Kubernetes for the backup point of view. So this is about the master node. Now the Kubernetes node. Kubelet, the primary node agent. It watches for ports that have been assigned to its node and like mount the port's required volumes, downloads the port secrets, runs the port's containers, periodically execute any requested container, liveness, props, reports the status of the pod, reports the status of the node. So it is basically a agent through which you can watch the pod. Kuproxy enables the Kubernetes service abstraction by maintaining the network rules on the host and performing connection forwarding. Container engine used to run the container, Docker by default or RKT optionally. Container runtime interface by the way to alternative runtimes. Pod, the smallest deployable object in the Kubernetes object model. It runs a single instance of an application. This is all about Kubernetes Node. Now proceed to the next thing. See here the Kubernetes Master and the Kubernetes nodes. The role of things like control panel nodes, handful through which we can control all the nodes, handful of the master processes, and much more important, and nodes like it's a work. These are also known as worker nodes, and where the all container application or the pods will execute higher workload, much bigger, and the more resources. Now proceed to the next. Accessing the Kubernetes cluster. Kubelet, the command line tool for deploying and managing the application on Kubernetes. Inspect cluster resources, create, delete, and update component, configuration file like this one, information for finding the accessing a cluster, and the bash auto completion. Dashboard, web-based user interface add-on, manage the application, manage the cluster itself. Direct access to the API, HTTP through REST, you can also access. Now to the next, controlling access to the API. A request for the API will passes several stages before reaching it, like request, it will send, then it will authentication, then authorization, then admission controls, and then you can access resources. Authentication, ensure that the user, it is who it pretends to be. Kubernetes has the two categories of users, service accounts and the normal users, managed by the Kubernetes and managed by an independent service. API request can be treated as a anonymous ones if are not tied to a user or the service account. Kubernetes uses client certificate, bearer token, and authenticating proxy or the HTTP basics or to authenticate API requests through authentication plugins. Sorry. The next thing, role-based access control, in short RBAC, RBAC, allows fine grained rules for accessing the cluster, allows dynamic configuration of policies through the Kubernetes API, uses the RBAC.authorization.kubernetes.io API group, define the roles and role bindings, in order to assign the permission to a subject. These permissions can be set cluster-wide, can be used for the cluster scope resources, non-resources, endpoint, namespaced resources across all namespaces, within namespace, and last for one single resource. Subject can be user, groups, and the service account. Now proceed to the next thing. Role in the cluster roles. Arabic roles contains the rules that represent the permissions. Permissions are purely additive. A role can be defined within a namespace or the cluster wide, and the cluster role like this, and the cluster role are not namespaced. So here is like kind role, API version, and the metadata, and then rules. So these kind of things. Now proceed to the next. Role binding. Role binding grants the permission defined in a role to a subject. Permission can be granted within a namespace with a role binding, or cluster wide with a cluster role binding. A role binding can use a cluster role. The rule will apply to the namespace of the binding, right? Kind role binding, API version like this, and the metadata, name, namespace, then subjects, kind user, name, div, API group, then role reference, kind, and the name, and then API group. This is about role binding. Now proceed to the next thing. The pod. Pod, as earlier we had discussed, like pod is the smallest deployable object in the Kubernetes object model. It runs a single instance of an application. It contains one or more application container, storage resources, a unique IP addresses, options about how the containers should run. Container in one pod are sharing the network namespace and the storage resources. A pod is scheduled on a node and remains there until terminated or evacuated. Pod do not self-heal by themselves. Controller. Now move to the next thing. Replica set. The replica set controller simply ensure that the desired number of pods matches its label selector, exist and are operational. If the label of the pod are modified and they don't match the label selector, then the new pod is spawned. The old one stay there. The replica set provide a declarative definition of what a pod should be and how many of it should be running at a time. So just one example is given, rs1.5 YAML API version, then replica set metadata like name, spec, replicas, selector, then match label, app, then template, metadata, the name labels, and the spec container, name, and an image. move to the next thing. Deployment. A deployment provides the declarative updates for ports and the replica sets. Deployment creates the replica set which create the ports. Updating a deployment creates new replica set and updates the revision of the deployment. During the update, ports from the initial RS are scaled down, while ports from the new RS are scaled up. Rollback to an earlier revision will update the revision of the deployment. The record flag of kubelet allows us to record current command in the annotation of the resources being created or updated. Strategy: how to replace the old ports. Rolling update default max unavailable or max search and recreate. This is all about deployment. Now proceed to the next thing. Demonset. A Demonset ensures that all or some nodes run a copy of a pod. When nodes are added to the cluster, pods are added to them. When nodes are removed from the cluster, those pods are garbage collected. To run pods only on some nodes, like spec.template, spec node selector, the pod is started on nodes that match the node selector, and spec affinity, pods created on nodes that match the node affinity. If node labels are changed, the Demonset will promptly adapt. Deleting a Demonset will delete the pod except cascade false. Update strategy: on delete and rolling update. On delete, the new pod will only be created when the old ones are manually deleted. Rolling update: after you update a Demonset template, all pods will be killed. Now move to the next thing. Services. Service, an abstraction which defines a logical set of ports and a policy by which to access them. The service map an incoming port to a target port. The ports targeted are defined by the selector. That's to endpoint. We can have the services without selector. So no endpoint object is created automatically. IP tables proxies depends on working readiness, probes, services, discovery, environment variable, and ordering. Environment variables are created when the pod is created. So requires ordering. The service should be defined first. DNS optional cluster add-on. No ordering is required. Service type: cluster IP. Expose the service on cluster internal IP only reachable from within the cluster default. Node port exposes the services on each node's IP at a static port. The service will be reachable from outside the cluster using node IP node port. load balance, expose the service externally using a cloud provider's load balancer. External name, map the service to the content of the external name field by returning a CNAME record with its value. These are the services. Now about volume. By default, the container file system is ephemeral, recreated each time when the container starts. So a clean state each time can be a problem for non-trivial applications. A pod can have multiple containers that are sharing files. A volume in the simplest form is just a directory which is accessible to the container in a pod. Remember that a volume in the simplest form is just a directory which is accessible to the container in the pod. The type of volume determines the backend for the directory. The pod definitions specify that what volume are provided, a spec that volume field, and where are these mounted in the containers. The containers are independently specifying where to mount each volume. The same volume can be mounted on the different path in different container. Secrets. Secret objects are intended to hold the sensitive information such as passwords. Safer than putting the sensitive information into pod definitions or Docker image. Secret can be used by the pods as files in a volume or injected by the kubelet. Secret can be created from files or directly specifying them. Kubelet create secret generic MySQL from then literal equal to password equal to my password, and checking secrets kubelet get secret MySQL -o 5ml. Config map objects are intended for passing information that tends to be stored in a single config file. Can store the key value pair or the plain configuration files. Kubelet create the config map spatial config, and the kubelet create the config my map. Check the values stored in the map. Kubelet get config map my map and passing values to pod. This is all about the Kubernetes. Thank you for the today's session.